Welcome to this online lecture about chemical names and formulas. In this first part of this lecture, I'm going to be talking about how to write the formulas and names for ionic compounds. The second part will be about covalent compounds. Please recall from what you've learned so far in this class that ionic compounds are made of a metal element combined with a non-metal element, and that when they combine, they transfer electrons so that the metal element becomes a positive ion and that the non-metal element becomes a negative ion. And then the positive charge is attracted to the negative charge, and that attraction holds the two ions together into a compound. And we call that attraction that holds those two together an ionic bond. So basically, you have to be able to either look at the formula for a compound and figure out what the name of that thing is, or if you are given the name of a compound or the two elements in the compound, you need to be able to write the formula for it. So this lecture is going to be about how to do those things. Let's start with an example. If we had calcium and bromine. So we've got two elements here, and what we're going to work on first is figuring out what the formula for the compound between calcium and bromine is going to be. We know because calcium's in group 2 that when it forms an ion, its charge is going to be 2+. And we know that bromine, because it's in group 7, when it forms an ion, is going to be minus. So we've got 2+ and minus over here. The easiest way to come up with the formula for an ionic compound is the same trick that I taught you when we learned about these charges and oxidation numbers. And that is to take the number that's associated with each one and switch it. And then that tells you how much of the element that you need. So for the formula for the compound between calcium and bromine, you would take the 2 that's part of the charge for calcium, and you'd use that for the number of bromines that you need, and then you'd take the 1, which is implied in the charge of the bromine, and then that's how many of the calciums that you need. So this is saying I need 1 calcium and I need 2 bromines. That's what that's saying. So how do we write that formula? Well, in the formula we use what are called subscripts to show how many of each element there is. We're going to write the elements together, Ca and Br, and then the subscripts go in this spot right here. They're after the element and a little bit lower and a little bit smaller usually. So that's where you write the subscripts. Now we need 1 calcium. So I could write the subscript 1 right here, but the rule in chemistry usually is that we don't ever, if the subscript should be 1, we just ignore that, because by writing calcium we know that there's at least 1 calcium in this compound. And then for the bromine we need 2, so we would write 2 right here. And so the formula for calcium bromide is CaBr2. That's the formula. So now let's get to the naming. The naming's pretty easy when it comes to ionic compounds. You just take the name of the first ion, which happens to be the same as the name of that element, and you write down the name of the first ion. So for all the positive ions, their name is exactly the same as the name of the element. So the name of this ion right here, Ca2+, the name of that ion is calcium, just like the name of the element is calcium. So the first thing you're going to write down here is calcium. That is the name of the first ion in this compound. And now we have to write the name of the second ion in this compound. Now the negative ions, the anions, they don't have exactly the same name as the element, but it's very close. So this element's name, oh, there should be an R right there. This element's name is bromine. So here's how this works. If you want to try to get the ion's name, you drop the end of the name, and then you're going to replace it with the suffix, which means a part that goes in the end of a word, I-D-E, ide. So bromine is the atom, and bromide, oh man, could I have written that any worse? Bromide is the ion. So that's the name of Br minus 1. That's called bromide. Let me clear up my D in my... There we go. Got to the edge of my tablet and it got sloppy. So the name of this Ca2 plus ion is calcium, so we wrote it down. The name of this Br minus ion is bromide, and we're just going to write that down. And so the name of CaBr2 is calcium bromide. That's pretty easy. You just look up the names of the two things in the periodic table and you write them down, and you just have to remember you put "ide" on the end of the negative ion. These names will always end in "ide" when it's just two atoms like this. So if it's just two atoms straight off the periodic table, it's always gonna, the second one's always gonna end in "ide" like that. And that's really all there is to coming up with the formula or the name of a simple binary ionic compound like that. Let's take a look at a slightly more complex example. I'm just going to go ahead and scroll this down a little bit here so we have a little bit more. So let's say we wanted to figure out the formula and the name for the compound made from, let's see, let's pick a metal, let's pick aluminum. It's a metal that pretty much everyone's familiar with. And then we'll pick a non-metal, I don't know, oxygen. Okay, so we'll do the formula first. If we look at the periodic table, aluminum is in group 13. It becomes a plus, 3 plus cation. It becomes a 3 plus positive ion. And oxygen's over there in group 16, so it becomes a negative 2. I'm sorry. Usually when we write charges, we almost always write the quantity first and then the sign. So it'd become a 2 minus oxygen ion. So the trick, hopefully you guys are kind of getting the hang of this, is you take the number for each atom, and that tells you how many of the other atom you need in the formula. So if we use this trick, we see that we need 2 aluminums and 3 oxygens. And so we have to write that using subscripts, which are these tiny little numbers that come after the element. So I'm going to write the first element, aluminum. There's its symbol. And by looking at the charges here, it looks like I need 2 aluminums, so a little 2. And then I'm going to write the next element, which is oxygen. And this 3 here tells me I need the 3, and the 3 plus of aluminum tells me that I need 3 oxygens. So that's how you get the formula, Al2O3. Now the name. Alright, so remember the name of cations. If they're just one atom, the name of the cation, the positive ion, is the same as the name of the element. So the name of this stuff right here is aluminum. Alright, and then do you remember the trick for the naming of the anion, the negative ion? You take the name of the element, and then you have to drop the end of the name, and you have to add the suffix "ide." Now sometimes it can be a little confusing until you've practiced this a bit, like what part of the name do you drop? And for oxygen, you actually drop the YGEN part. So the name of oxygen, when it becomes an A2 minus ion, is oxide. You see how that works? So the name of this ion is oxide, so we write the name of it down next. And we see that the name of Al2O3 is aluminum oxide. So that's how you do it for basic ionic compounds. Compounds made up of just 2 different elements like this. But there can be sometimes one more thing that might confuse you, that kind of complicates it a little bit, and that's because not all ions are made up of just one atom. There are actually ions that are made up of many atoms, and so their name is polyatomic ions. And so hopefully you've got your word skills are up to snuff, you see this prefix poly, and you know that that means many. And so you see that this word means many atom ions. And that's exactly what they are. They're ions made up of several atoms bonded together. So I have, let me see what this looks like. Yep, I've got a little chart right here. And this chart is actually from the textbook that we've got in the classroom. And it's a list of the more common polyatomic ions. And if you look at these, you can see that they are, all of them have more than one atom in them, right? So like even like sometimes kids see peroxide right here and they get confused. They're like, well, that's just oxygen, that's one. But it's not just oxygen, it's O2. O2, right? So all of these, it's only one element, but there are two atoms there, and they're covalently bonded together, and then that group has a charge. And that's exactly how these ions work. These atoms are covalently bonded together, and then that whole group of atoms has a charge. And usually what I like to have kids do is I like you to try to think of these things kind of as one thing. A lot of times in chemistry that makes it a lot easier for you, whether you're trying to balance something or what. But if you think of these as like one thing that has a charge, then you're good to go. So all of these polyatomic ions are -1, all of these are -2, and all of these are -3. Now, the way that you come up with the formulas and names is exactly the same. It's just that when you see one of these polyatomic ions, when you have more than 2 different elements in your compound, you have to know that you have to look at this chart. So I'm going to scroll down a little bit more here, and let's take a peek at how this would work. Let's say I've got, magnesium. Whoops, let me change my color back to black there for magnesium. And then I've got some NO3. All right. So we're going to look at the periodic table, and we see that magnesium's in group 2, so it's going to be 2+. Now NO3, what the heck? That's 2 different elements. So right away, a bell should be going off in your head. That's a polyatomic ion. So you have to look at the chart over here. When you look at the chart over here, we have to kind of find, NO3, unless you know what it is. After you've done this enough, you kind of get them memorized. But see, NO3 is right here, NO3, and it says that its name is nitrate, and it says that its charge is -1. So the nitrate is a 1- ion. And then from this point on, that was the only thing you have to do different. You just have to recognize and acknowledge, hey, look, there's more than one atom here, and I've got to look at that chart to find out the charge of that thing and what its name is. So we do the exact same thing that we always do. We take the number that's associated with the charge, with the oxidation state, and that tells us how much of the other thing we need. So this tells us that I need 1 magnesium, so I'm going to write 1 magnesium. And now it's saying that I need 2 nitrates. But nitrate already has a subscript because nitrate is a nitrogen with 3 oxygens bonded to it. So we've got NO3. And if I put a 2 subscript after that, that would be really confusing because it looks like NO32. And that is not what we want. So the way that we do this in chemistry is we always put polyatomic ions in parentheses when we need to have more than one. And then the 2 goes on the outside of the parenthesis. And so what this is saying is you've got 1 magnesium with 2 nitrates. And that's how that works. So that's how the formula works when there's a polyatomic ion involved. Now, I'm going to run out of time, but we're going to quickly do the name. It's very easy. It's the same thing. The name of magnesium is magnesium, just like the element. The cation, as long as it's one atom, it doesn't change. But now we need this name of the second ion. We need the name of this stuff. And we probably don't know it off the top of your head, so you have to look at this chart. So NO3, it says in this chart, and you have to be careful because these names are very similar, but it says that NO3 is nitrate. So Nitrate, nitrate. And so the name of this stuff is magnesium nitrate. So that does it for the ionic compounds. Thanks for watching, and as always, if you have any questions, please ask in class.